So our second part of 6.4 lesson for Algebra 2 kind of alluded to it in the previous lesson where we talked about, x to the 1/2 power being the same thing as the square root of x. And today we're going to go into further detail about that. So, fun fact, radicals can be rewritten as expressions with rational exponents. So a radical is what you guys know is like square root, cube root, fourth root, fifth root. And then a rational exponent just means that you have a base of whatever the original base was. But a rational exponent, remember, meaning it's a fraction exponent. And they're equivalent ways of saying the same thing. So we have to be able to maneuver between the two forms before we can move on in the nonlinear functions. So this is kind of the shape of what you're going to see. And I put parentheses around where we're going to fill in some words for some vocab. So the number that's in front of the radical symbol, radicand I believe it's called, is called the index. And it tells you which type of radical it is, because you guys know this to be the square root. There's technically, we don't write it, but there's an understood 2 in the corner. Because if it was a cube root, we would put a little 3 in the index. And if it was a fourth root, we'd have to put a little 4 in the index. So make sure you understand that this is a tiny little superscript, almost like an exponent in the index position. Do not write it like this, because that means 3 times the square root. So that's not what you intend if you're trying to write cube root. And then underneath the radical symbol, you're going to have some form of a base somewhere here. Base could be a number, it could be a variable. And then up in the exponent, this is referred to as the power, or some people refer to it as literally the exponent, okay? Now just to be really fun, the exponent can actually slide into the radical symbol. Who would have thought, right? So you might see it written this way, where this is still the index number here. You're still going to have the base inside the symbol. And then the power can actually be inside the radical symbol or outside. And then it's kind of one of those weird things about math that you learn. It actually doesn't matter. So go figure. All right, so here's the conversion formula. I'm using n to represent index. I probably would have been smarter, but i's are kind of hard to work with in math. Plus later on, we're going to learn that a little lowercase I means something else. It's actually a number. Spoiler alert. Okay, so the way we rewrite it from radical to rational exponent is you keep the base of x, and then it's whatever the power is divided by whatever the index is. So using our property, or our vocab, I should say, we have index here, and then I'll call it the power. So it's going to end up being x to the power divided by the index. But even if you don't see an exponent in the power position, there's always a 1 there. The radical symbol, however, if you don't see one, if you don't see an index number, we'll talk about that, but it means there's a 2. There is no such thing as a first root. All right, so here they want you to, and at this point in our lesson, so if you're absent, you're going to get a little chart of powers and roots and things. So we're going to have to refer to that chart until we get more familiar with numbers. But I want you to take the nth root of some particular base. So in this case, it's the third root. So they put a little 3 in the index. And then your base was negative 125. And now we set it up already for you, but I want you to take it further. I actually want you to figure this out. So on your chart that you're going to get, you're going to find there's columns and rows. I hurt my wrist. And you're going to look through, I would look through the cubic column, and you're going to see 5 to the third power is 125. Well, the only difference here is the base is negative 125. And you could also type this on your calculator. There is a cube root symbol on your calculator. There's also an nth root symbol on your calculator. Get rid of this. Delete. So in the math menu, if you go down to number 4, that's the cube root symbol. But if you need something other than cube root, like fourth root or fifth root, we're going to have to use this guy. So we can pull up cube root and then type negative 125. So using my chart, I knew that 5 to the third power was 125, so negative 5 to the third power must be negative 5. Negative 125. I don't know. Anywho, the answer to this is negative 5. So here we're going to set up the fourth root. So put 4 in the index. My base is a 16. Again, you could look down your chart and find where 16 shows up. It's going to show up in the row of 2s, like 2 to the fourth power is 16, so that means the fourth root of 16 is 2. Again, could also use my calculator. If you have an older calculator, this menu works a little differently. But for these newer ones, when you pull up the x root, or back up, there we go. I can kind of toggle between the index and the base. For the older ones, you would have had to have typed 4 before you pulled up the x root. So the 4th root of 16 is, again, the hope is that at some point you understand powers of numbers and you start memorizing these. All right, so this next section, we're just going to toggle between the two forms. Simplify if possible, okay? So rewriting this into the other form says you take the base of d, and then rewriting as a rational exponent, it's going to be 2 over 3 power. So d to the 2/3 power. Here, it's going to be e to the 2 over 4 power, which, yes, you could reduce that to e to the 1/2. Yes, that's square root, but that's what they wanted us as an exponent. All right, so here, 3 to the 4/5 power. 10 to the 4/4 power. Again, reduce if you can, so that's 10 to the 1st power. This one's kind of fun. You have two different bases, so you can interpret them separately. So this is e to the 2/3 power and f to the, there's an invisible 1 on f, so 1/3 power. Those are not the same base, you can't do any combining. So now we're going to go the other way. We're going to take a radical symbol. We're going to place the number in the index. So remember, the denominator of your fraction is the index. Since it's a square root, you can put a little 2 in the index, or if you leave it empty and just put a radical symbol, it's assumed that the number right here is a 2. It's kind of like when you have a coefficient. If you don't write a coefficient, we assume it's a 1. In this case, if there's no index written, we assume it's the smallest possible one, which is 2. The base of this problem is a 2. And the exponent, so you can write like this or this, and the exponent is a 1, power is a 1, so you can either write it outside like this, or you can write it inside like that. Does not matter. So you can imagine these are super fun to grade, right? So we have a radical symbol, and it is the 5th root, so that's the index is a 5, you have to write that. The base is an a, and then the 3rd power can be written either outside like this, or you can write it inside the radical like that. Here we have a 5th root again because of the denominator of the fraction. Base is 5, and it's being raised to the 2nd power, or you could write 5th root of 5 squared. All right, here we have the cube root. You need a cube root in the index, x to the 2nd power. You could write the other form. I don't want to write over my base. All right, so we have 4th root of base 4 to the 1st power. All right. Okay, so this is going to be fun. We're going to try to simplify all the way down to like the nicest answers we can get, and we're going to try to do it without a calculator because I'm well aware that you guys could just type these in and then hit math enter and get the most reduced fraction you could. But remember, there's a whole section on the SAT where you cannot use a calculator, so we want to be able to do this. So here we have 9 to the 3/2 power. My brain likes working with exponents, but my brain does not like simplifying rational exponents well because I can't really think like this. So I'm going to rewrite it as a radical. So it's the square root, you can put a 2 if you want, of 9, and then raised to the 3rd power. And I actually think we can handle this one, guys. The square root of 9 is the same thing as saying 3. So this is 3 raised to the 3rd power, which is 27. So again, you got that chart that you can reference, but at some point we want to understand that 3 to the 3rd power is 3 times 3 times 3, which is 27. All right, here we have a couple of different options. You might want to like halfway use exponent properties and then go back to radicals. So first thing I notice is it's a negative exponent, which means whatever I'm about to do is actually going to end up in the denominator. So what if I rewrote it like so? So it's the 5th root of 32 squared, but it's all in the denominator. So the 5th root of 32 is something I would find on my chart. Turns out that's just a 2. So my fraction now is 1 over 2 squared, which is 1/4. All right, here, this one's going to be easy. Look at this. The 1/2 power, remember, is the same thing as, and you can write it like this for now if you want, but the 1/2 power is the same thing as the square root, right? It's square root of 4 to the first power. So 1 over the square root of 4, that's just 1/2. Notice I'm not using plus or minuses because I'm not solving. All right, here we have, it'll turn out to a square root of 16 raised to the 5th power. Okay, well, square root of 16 is a 4. Oh boy. 4 to the 5th power is, I don't have my chart in front of me. I'm going to cheat. I always forget this one. 1024. Such a good answer. That is on your chart. All right, and then this last one, same thing. I'm going to make sure this ends up in the denominator, but I'll rewrite it as the cube root of 27 squared, but all in the denominator. So cube root of 27 is really a 3, and this is 3 squared, so that's really a 9 down there. Very nice. We can do that without a calculator. Easy. These you have to use a calculator. So you have a couple of choices. You could literally type it in as it is on the calculator, which is kind of a pain in the tushy because to write radicals on the calculator, especially something that's higher than a cube root, you have to use that x root thing and then toggle between the index and the powers. And then you got to use parentheses and then cube it anyways. I personally just always change it to a rational exponent, and then it's really easy for me to do on the calculator. So all I have to do is type in 5 to the 3/4 power. Now, if you have an older calculator, you're going to have to type it like this. If you have one of my newer calculators, you won't need the parentheses because you'll stay up in the exponent position. So 5 to the, and then 3/4. See how I never got out of the exponent, so it stays up there? The older calculators, however, you're going to have to use parentheses around your division. So 3.4. The reason I'm telling you in the instructions to use a calculator on these is because they're not nice. All right, so here again, I'm going to rewrite it as 3 to the 4/3 power, and that's how I'm going to type it on my calculator. So 4.33. If you need to pause the video to go get a calculator, please do. And then here, I'm going to rewrite it as 5 to the 2/3. I'm going to grab my calculator because I told myself to do that. Oops. 2.92. Jeez. There we go. So if your directions say use a graphing calculator to do something, you need to do that. All right, so after that set of notes, it begins a bunch of practice problems. I'm not going to do these for you because in all likelihood I gave them to you for homework. The first 2 sections are just like in our notes where we go between the 2 forms. And then we're going to evaluate, and then it's kind of a mishmash here. So some of these come out really nice and some of them don't. So do what you need to do in the different forms. If it's got variables, you're not going to be able to get a nice answer. So don't even bother working with your calculator when there's a variable base. I get a lot of kids who try to type in like number 27 on their calculator and they don't realize that the letter A actually stands for something on their calculator. It's whatever the last person programmed A to represent. So watch out for that. All right. Enjoy.